Hi, this is Dave Murphy, Customer Success Director here at Split. Welcome to this video with our CTO, Pato. Welcome, Pato.
Thank you, Dave.
We'll be talking today about implementing the Split server-side SDK and some of the things you might want to consider as you do so. So, Pato, what might you want to consider when you implement the Split SDK on a server?
Well, Dave, there are a few things. Number one is your technology powering the backend side of the house a multi-threaded or multi-process environment. In a multi-threaded environment, it's much easier to share memory across threads.
Sure.
And therefore to have that common set of information that we need for the SDK to operate. But where in the cases where you have a multi-process environment, and becomes a little more tricky to share state. So in those cases, examples of that are PHP and Python, or some frameworks, or Ruby on Rails, for example, depending on the web server that Ruby uses. We advise customers to use an external cache. And that cache is the one used to store the information that the SDK need to evaluate a flag.
So this would be our Split Synchronizer.
Exactly. So we call it Split Synchronizer. It's a microservice, Docker container friendly, that keeps that Redis cache up to date at all times. So SDKs can access that information to evaluate the flag and return the flag information to the caller.
Okay.
So that's number one. Number two tend to be fine-tuning of parameters. Those are rarely changed, I would say. 90 to 95% of the cases, customers don't have to change anything. And that's the result of many years of iteration to find the right tuning.
Right, but we give them the option to. So which ones might they want to or need to change, and why? We
give them the option. The number one option that again few customers change is some notion of timeout that we have. When SDK comes online, it requires a connection to Split backend services to download all the flag definitions. Because of that, Split is really fast at evaluating flags because there's not really I/O with the network. It's all in memory, and that's why we need that shared state. But of course, the information doesn't flow immediately. It takes a few milliseconds. We're usually in the couple of 100 milliseconds. It's really fast. But if by some circumstances the payload that needs to be downloaded is bigger than usual, we require a tiny bit of change of that timeout. We refer to that internally as block until ready timeout.
So a user might change those, but how are they going to know what to change? I know that we have, for example, a runbook on our help center. Is that a good place to go and look to figure out what they're going to change?
Yeah, so for example, when you're using Split Synchronizer, so that behaves as a cache to have all the rules stored for the SDK to interact with. But in addition to that, when the SDKs produce flag evaluations, they need to send the data back to Split. So they send the data back to the Synchronizer, and Synchronizer in turn send it back to us. And of course, the memory is something to keep an eye on. So for that, we provide a comprehensive runbook with information that any DevOps or infrastructure person will want to know to monitor the health of the process. In addition to that, to make things very simple, we provide with small calculation coefficient. It's just a number that when it's above 0, it means that it's healthy in terms of data is collecting and data is taken out. But when it's below 0, it requires attention. Usually things that you can tune are things like how much data do we send per unit of time, and how many threads are in charge of taking data out of Redis and back to Split, and also how often that happens. Again, those values don't have to be changed very often. At this point, everything is tuned to be good for the 95% of the use cases. But in case they're not, we provide that comprehensive runbook and ways to monitor the service. So all of this, by the way, is available through the Synchronizer UI, as well as an API that can be used to query the data and report to different tools. And of course, for the backend languages that don't require Redis to operate, memory footprint is something to look into. Again, unless you have a super high throughput environment, defaults are fine, but otherwise, keeping track of the memory fluctuation, make sure that there's nothing building up, like we say in the industry, that produces any memory leak. Other than that, everything should be fine from the default standpoint.
So we provide also a simple formula that people can input the values that exist for their particular implementation, so they can see if they need to change or tune the
Correct.
parameters.
Usually the input to that formula are requests per second, how many users you expect concurrently being accessed per unit of time, usually a minute. And those two parameters are pretty much good enough to produce an outcome on that formula and see how you compare about the baseline.
Okay, and most of our customers deploy the SDK when on the server side and in a server somewhere on a server farm or up in the cloud or something along those lines. Does this change the approach or the parameters that we might use if we're deploying in a microservice or something like AWS Lambda?
Yeah. So as you know, Lambda has been a popular way to have some functionality running without worrying about the server in which it's running. Mm-hmm. So technically, you define it as a function. Most of people that we have customers using Split on the Lambda environment, they tend to follow this layout. So you have the function using Split SDK, this external cache that we call Redis in this case, where all the rules, the flag definitions live. And then we have the Split Synchronizer, potentially also running as a Docker container somewhere in a cloud provider, maintaining the Redis cache up to date. Lambda function gets initialized, access information from Redis to evaluate flags, continue its process and dies, and then it repeats over and over again.
So another question that I think we see quite a bit is, or at least there's a lot of conversation around, is we give someone the ability to, when the user gets initialized, go out and get all of the evaluations for all treatments and render them in the UI, or we can just get the treatments on demand when the user hits the particular split. What do we usually recommend, or what do we see our customers doing?
This is a good question where the typical answer is it depends. Both cases are valid, depends on the user experience that you want to provide. So for example, with the popular frameworks in the UI today like React and Redux, it's very common on customers evaluating all the flags for the user in session at once, and then use that information throughout the session. So there won't be any evaluation again. The only tricky part of that is one of the power of feature flags is you can realize that you made a mistake and hit a kill button that we have, mm-hmm. or do a rollback without changing code. And then if you only evaluate a flag once and you have no way to react to that, then you're losing part of the value proposition. But when the user comes again in the next session, then if the feature is taken away, then it won't see it. Now the other side of the question is, so what happens if I don't do that and then I evaluate on demand? So the good thing is that you only evaluate flags that the user has been exposed to throughout the session.
Right.
But the downside is that you have the risk of changing the flag definition somewhere in the session and produce a not consistent effect on the user experience. So it depends on the risk profile and the functionality they want to provide. One approach or the other one makes more sense. And last, I would say that particular use cases like entitlement, if you're using feature flags to gate your application based on what functionality you want to provide to your free tier customers versus the ones belonging to the professional plan or enterprise, that's the best use case to evaluate all the flags at the beginning, because you want to really control what areas of your website one user, say that the free account can see, versus the enterprise.
So when we evaluate all the flags, are we sending an impression for all of those flags back to Split?
Yeah, every time that Split SDKs, and this is valid not only front-end, but any backend language as well, we collect that telemetry. That's one of the things that are unique about Split, unlike other service providers, is that we have all of that information and we retain it for many weeks. So you can go back in time and see what customer experience some person saw 3 weeks ago, because we collect every single evaluation.
It sounds like, though, that if someone's doing experimentation, they may not want to evaluate all of the flags up front. They may only want to evaluate or send impressions for users who actually hit the split if they're measuring it against a specific metric.
Absolutely. That's one of the good reasons for which someone might decide to evaluate splits on demand, because then knowing what feature, what user experience a customer were really exposed to and interacted with, becomes really important when it comes to experimentation.
Okay, thanks very much, Pato. Is there anything else that someone should consider when they're implementing our SDK on the server side?
I would say don't fear the flags. They provide great value. They're easy to implement, and at the end of the day, it's another tool and piece of the delivery, continuous delivery motion that will help you deliver value to your customer faster, and to the opposite, when you make a mistake, to take that back in a matter of seconds. So at the end of the day, you're better off using feature flags, and it's something that is here to stay.
Great, thanks Pato, and thank you all for watching. You can find more information about the topic here on the Help Center, articles, examples, and best practices. So enjoy.